Hey everybody, this is Aaron Murakami with sidebandsgenerator.com. What we have here is the 3.1 megahertz 1.5 to 2 watt sideband generator developed by John Bedini. It's called the Bedini RPX. This is a larger test unit that I have. He custom made this for me. It's about a 10 to 12 watt unit. These are not going to be available to the public, but it does the same thing that this does. The experimental time for this is maybe 3 minutes. This is maybe 12 to 15 minutes. These are only experimental test devices for experimental use only, with absolutely no claims given, and so we can't respond to any emails asking us any questions other than what its intended use is, and that is simply an experimental test device. So what I'm going to show you in this video is these were first disclosed and made available by John Bedini at the Energy Science 2016 this year's Energy Science and Technology Conference. And at that conference he gave a presentation that was a couple hours long on what this is all about. Several presentations, and had to take a couple breaks through it, and gave a lot of information. Thankfully that presentation was basically pre-recorded, and there's also a book available at Bedini RPX book.com. And that book even has schematics on how to build one of these. It's an analog version. It works exactly like this. This is a digital version that was just a little bit more simplified for manufacturing purposes, but the analog version does work exactly in the exact same way. And so if you are savvy with electronics and you understand what's in the book and the video, you're going to be able to build one of those. We hope to be able to make these available once again in January or February of 2017. And at sidebandsgenerator.com, if you go there and you scroll down to the payment area, join the notification list, and you'll receive an email once these are available again. So what John Bedini did was he made all the plasma tubes obsolete and all the high costs obsolete, where you can put one of these in your hands for not much money, and all you need is one of these little handheld function pocket generators from you can get from Amazon, some electrodes, and a little $20 something battery pack, and you're good to go. And this has really never been done before. And once you see his book and video presentations, you're going to know exactly why it is producing the real RIFE, R-I-F-E, frequencies like a real RIFE machine. You do not need a tube, and you can do it with this small handheld technology for a fraction of the price. And a lot of the companies out there selling these function generators, these little square wave generators at these low audio frequencies, and claiming they're going to do this and that, those are all phonies. That technology is a fraud, and it has absolutely nothing to do with what RIFE was doing. And in that book and DVD set at BediniRPXbook.com, you're going to see that. Also on sidebandsgenerator.com, and those books are available by a totally different company. I'm just working with sidebandsgenerator.com that has these experimental test devices, and there's a couple videos on there you can watch. So in this video, since we've released these at the conference, and quite a few people have gotten these into their hands, are lucky enough to be an owner of these, and after the conference, up to a few months after the conference, some people are asking how to hook up the spectrum analyzer and all this, and to see exactly how it's working. Well, the basic concept is that there's a programmable oscillator that's going to produce a 3.1 megahertz, which is a 3.1 million cycles per second signal. And that's basically going through a certain circuit, which is a buffer circuit to protect it. And then we have the function generator putting out a certain frequency, from a low frequency to a high frequency, and certain increments at a certain voltage at a certain speed. And what the output of that does is it bucks into that buffered fundamental frequency, and what it does is it hits it and it kind of distorts it, so it's no longer 3.1 megahertz, and you get these ripples off of it, which are known as sidebands. And these sidebands are frequencies that will wind up hitting every single RIFE frequency without having to ever punch it in. What that also means is it's all automatic. You don't have to punch the frequency in, and it will even hit frequencies he did not even discover yet. And so that's one of the primary benefits to this method. And also those sidebands are going through an RF amplifier to boost the power, and then it's mixed with a certain pump wave which delivers current, and that current is delivering those sideband frequencies to its source. And with that pump wave, it completely obsoletes the need for the big plasma tubes and the big high-end, heavy, expensive equipment. Okay, so what we're going to do is I'm going to turn this unit on. This has a built-in battery here. But first, I want to show you exactly how to couple the spectrum analyzer to one of these, because that's one of the questions that we've received, is basically how to do that. Let me see if I can get that to focus in there. So what we have is the spectrum analyzer, by the way, has a RF input, radio frequency input. That's an N connector. You need a 50 ohm impedance line, and then the output of that is basically just coming to one of these probes. This probe is just going. This probe is going to the positive and negative electrode to look at the pump wave and how it's modified by the sidebands and the sweeping action. This probe, the negative is coming to the negative, but the positive is coming to this twisted wire, and you can see it's cut at this end. So in Bedini's diagrams, you can see that this is called a gimmick. Many years ago in the electronics industry, if a company wanted to save money and they didn't want to spend money on a capacitor, what they would do is they would simply take the wire, and where they wanted a capacitor, they would just twist it up a few times, maybe an inch or so. That'd build capacitance, and that would be called a gimmick, because it is a gimmick in the literal sense. And it's G-I-M-M-I-C-K, just like gimmick would typically be spelled. In this case, this end is cut right here, so what it means is capacitively coupled to the positive electrode. So one of the probes is going to a wire which is being wrapped around, and it's not connected to anything. This positive electrode is connected to a wire, it's being twisted around, and it's not connected to anything either. And so what that does is this capacitance here is how the spectrum analyzer is picking up that frequency, so we can see the fundamental and we can see the sidebands. So it's very important, don't electrically connect it. You can't, within these voltage ranges, it'd probably be safe for the spectrum analyzer, but for extra protection and security for your device, you just capacitively couple it, and then you don't really have to worry about that. And there's ways of taking this output through capacitor plates. You can take it into an antenna, and you can receive it by a RF antenna going to the input of the spectrum analyzer, and you can look at it that way too. Okay, so now that we know how to properly couple it safely to this using what's known as a gimmick, capacitively coupled twisted wire setup, we're going to look at the spectrum analyzer itself. So the first thing I'm going to do before we get into the sidebands is, I'm not going to turn this on yet to distort the fundamental. I'm just going to turn it on, and instantly you're going to see that we have some action here. Now on the spectrum analyzer, if I go to frequency, I already have it punched in 3.1 megahertz. Now at 3.1 megahertz, that's what the programmable CMOS oscillator is set at, 3.1 megahertz, and you can see that at multiple decimal places it's right on the money. Okay, so this is the fundamental. And so what I'm going to do now is I'm going to turn on this sweep generator. If you go to sidebandgenerator.com and you scroll all the way to the bottom of the page, you're going to see the proper spectrum analyzer model to be used for this. You can use a lot of different spectrum analyzers. I'm just using the exact one John got. Actually, this may be a little bit more advanced unit because I have a generator output option here, and I think his just had a black plug right here that was recessed into the machine, so he didn't even have it, so it was a little bit cheaper model. And so, but in any case, sidebandgenerator.com, scroll to the very bottom of the page and you're going to see exactly what model he's using. Now this right here is just $100 delivered on Amazon function generator. The test unit for a function generator to put in the low, the high, the type of sweep, which would be linear, the speed, and the increment, cycles per second increment of the sweep. This actually came out of John's shop right here. This is a BK4014B. This is also linked on sidebandsgenerator.com. These are probably going to be about $400 a piece or so. On Amazon, this is $100 delivered on Prime. You don't have the luxury of pushing in the numbers. You have to hit a button and it'll scroll up to the numbers. And so you have a low frequency, high frequency. On this right here, the sticker says 50 to 150 kilohertz sine wave only. Okay, on this, I think the minimum is 100 cycles per second. And 150 is no problem. You can set sine wave. And so what that does is that's going to sweep and it's going to hit that fundamental and create the ripples, and the ripples are going to hit every single rife frequency, and that's what's the most important thing about this. So what I'm going to do is I'm going to turn this on, and as soon as it boots up, you're going to see the ripples off of that fundamental, because you're going to be hitting the site, and there it goes. So it's already creating the sidebands right there with all these ripples, which are going to sweep through and hit every single rife frequency. So right here you can see waveform, sweep is on, sine wave, it's at about 2 volts. I think 2.1 is recommended. And so as this is sweeping through the frequencies, distorting that fundamental, what you're going to see here is that you have all these sidebands. So I already have this set to where that number 1 right here is a marker for the fundamental at 3.1 megahertz, and you can see that it's accurate up to several decimal places. You can see this number 2 right there. If I go to marker, and if I scroll through the markers to 3, 4, 1, 1 is going to be set at 3.1 megahertz. If I hit marker again, select the marker number 2, that means this number right here that you see riding up to the peak, coming back down and coming back up, I'm going to be hitting these frequencies right here. So for example, this is from a sideband calculator. I'm not showing the names of the frequencies because it's irrelevant, because there are no claims for this device other than it's an experimental test device. It's a bunch of electronic components put together that just happens to put out all the frequencies that Rife was using. And so what we have here is these are the frequencies right here. And if you subtract these frequencies from the 3.1 megahertz fundamental, what you're going to find out is that you're going to get these numbers right here, which are different harmonics of these audio frequencies. So again, a lot of companies are selling devices that put out these audio frequencies claiming it's a Rife device. They're all fake. They don't even know what you're supposed to do with those audio frequencies. You're supposed to use different harmonics of these to bounce them off the fundamental in order to create the sidebands to create these higher frequencies right here. So what we're going to do is, let's just take some example right here, like this one right here. Okay, we're selected at marker number 2, and what I'm going to do is I'm going to punch in 2.988.034, and when you type in those numbers, you get an option for gigahertz, megahertz, kilohertz, or hertz. And I'm going to hit megahertz right here. Okay, so that marker number 2 is writing those sidebands so that you can see that every time it hits a peak, like right now, it's hitting that exact frequency. Now, even though I typed in 2.988.034, this is 2.988.217. But if you study Rife's work, you can be within a certain margin of error, which is way greater than that, and it's still effective. So this is just an example of how to use this. By hitting a marker, you dial in the frequency, and so number 1 is on the fundamental, and number 2 is a frequency that corresponds to a certain something that you're targeting, utilizing this fundamental and the audio frequencies we're using. So every time it hits the peak, boom, it just hit it, and it's going to repeat over and over and over. It's hitting that frequency. Now let's just say we go to marker number 3, and I just randomly pick, I don't know, this right here. Now if the frequency is lower than the fundamental, get that in focus there, if the frequency is lower than the fundamental of 3.1, it's going to be on the left side obviously, and if it's on the right side then it's higher. Okay, but I'm just going to go 2.955464. Oh, got to hit normal right there. Let's do it again. 2.955464 megahertz. And now we have marker number 3. Now each time marker number 3, let's see if we can get right on there. Let's see if that's going to focus. Each time 2 hits that peak, we're on the right frequency that we're looking for, and each time number 3 hits a peak, it's also hitting that. Now you can see that the fundamentals here, this is the first sideband and that's the second sideband. The closer the sideband is to the fundamental, the stronger the amplitude is for that particular frequency getting hit. So you can see that number 2 and 3 are pretty much chasing each other. Zoom out a little bit there, see if we can focus back on it. So 2 and 3 are chasing each other, and they're fairly close to each other, and one hits the peak and then the other hits the peak, which means both those frequencies are getting hit. And did I ever punch in the exact frequency into the device right here? The answer is no. All I did was, and this has nothing to, the spectrum analyzer has nothing to do with what frequencies it's hitting. It's just looking to see if it's actually hitting the real right frequencies, and it is. And this is what the real Rife technology is supposed to be doing. So if your technology doesn't do this, you don't have the real thing. So what this is doing is, you got the fundamental, you're injecting these other frequencies, the lower frequencies, creating the sidebands which are going to hit all the different Rife frequencies. So I'm hitting two frequencies right there over and over on the third and the second, fourth, third, second, and even first sideband, it looks like, without having ever punched in those numbers. And as it's sliding up and down those peaks, those are all other frequencies that it's also hitting, even if Rife didn't know that they corresponded to anything. Okay? So that pretty much shows you that this is doing exactly what it's supposed to be doing. Okay, so what we're going to do now is we're going to look at the scope, and we're going to look at the total output to see if these sidebands are manipulating the square wave output, and instead of the square wave having a flat top and then flat bottom, it's going to be manipulated and modulated by these sidebands, and that square wave is current delivering those sidebands to wherever they need to go, and that's what makes the tube obsolete. So let's zoom out a little bit here so we can see our whole setup. And what we're doing is we're looking at the scope right here. We can see that the sweep is modifying the square wave with the sidebands. And it's carrying it like packets of information. See that right there? It's kind of hard to trigger on this, but so it's kind of hard to see this on here, but instead of a normal sine wave, we have this going on where the sidebands are manipulating that square wave output, and that square wave is actually a delivery mechanism taking these sidebands where they need to go. And these are like the packets of information where it's piggybacking on there. And that's the delivery mechanism. And when you look at Bedini RPXbook.com and you actually see what the pump wave is about, which is what this is it's pumping it in these packets, boom, 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 with these sidebands. That's delivering it. It makes the tubes obsolete, and so this is the most significant breakthrough for the public on Rife technology that there ever has been. And all credit goes to John Bedini and the people he's worked with over the years to be able to just, I've seen him at work for almost 20 years non-stop, and he's always boiling it down to the simplest possible thing. So you can see these little packets. I'd call it like an information packet, little chunks, and each chunk is delivering these sidebands right where they need to go. And so anyway, the conference where it was disclosed at was EnergyScienceConference.com. The sideband generators are available at sidebandgenerator.com, and the book and DVD set from John Bedini is available at Bedini RPXbook.com. And between all of that, it is the most definitive expose on what the Rife technology is about. And it's just absolutely awesome to see these sidebands being created like that, where we literally have all the Rife frequencies being hit just automatically as the sweep of these so-called audio frequencies are distorting that fundamental. And with pump wave output, no tubes necessary. The little unit here, the pocket generator, the little lithium-ion battery, it can all just fit in a little case about like that, portable. Charge that battery up once, you're going to get many hours of experimental running time. Sidebandgenerator.com and another company is offering the book and DVD series, which is or book and DVD set on the Bedini RPX technology, and that's at BediniRPXbook.com. So I hope that kind of gets you to understand a little bit more about how this works, what the sidebands are, what the importance is. Because right there you got two different sidebands getting hit, these frequencies, and the closer it is to the fundamental, the stronger. Fourth, third, or second sideband coming up to the second sideband right next to the fundamental, which means a lot of power on those specific frequencies. And there's a whole lot of frequencies, and that hits all of them one right after another. So I hope you enjoyed that, and that shows you a little bit about a little bit of insight on the Bedini RPX. Absolutely revolutionary technology, and one of the latest and last great legacies that he left us with.